So default prop values. What are default prop values? So when we have prop types and that we brought into our project, we can we know that there's some props that are required to make our project work, right? Without that that prop being passed down to that specific component that we're working in, the component will not work. Either we'll break the browser and we'll get an error, or users will be clicking on something and it won't work. You know, something is going to be broken. There are props that don't necessarily have to have a value. For example, let's go to our to-do list here, and let's find a prop that is not required. So if we go into our to-do list, let's say that we're grabbing our to-do list from an API. There's going to be a period of time from the moment we kick off our API call to when that API call returns back to our browser and brings back data. Usually this is like 600 milliseconds, or like 0.6 of a second, or maybe it could be up to like 2 or 3 seconds. There's a period of time that our user will be waiting for data to come back. So we don't want to just have maybe we want to render the rest of our app, like our header and our form, and not our list before that actually comes back. So maybe our list here doesn't need to be required. So let's do this. Let's go to our app.js, and we're going to we're not going to pass in to-dos just straight from this list right here. Instead, we're going to say to-dos is null. And that gives us a problem because null does not have a .map function on it, right? There's not a .map method on the null type in JavaScript. We can't do null.map. So at this point, we're thinking, okay, well, it has to be required, right? There has to be some way. Like if this is not required, then we're going to break our application. So one thing we can do to get around that, because we don't want to require to-dos, we do want to require our function. So we say is required in our function. What we can do is we can say, well, we're not going to require to-dos, but we're going to give to-dos in this component a default value. So we're going to add another special property to our component called default props. And we're going to give to-dos a default value of an empty array. And that should have taken this away because empty arrays do have the .map. So let's go see why this is happening. Default props. Well, that should have worked. What if we don't pass it down from app.js? Oh, okay. So we took out to-dos. We're not passing to-dos down on the to-do list. So I was a little mistaken on this. I thought it would override a falsy value like null. But it doesn't seem to be overriding this. So before we took away this line, before we took away to-dos equals this.state.to-dos, we're passing down null right here, right? And default props is not going to override that value. Instead, what default values is going to do is if we decide not to pass down to-dos and to-do list doesn't receive any to-dos at all, then it gives the default value of an empty array. So the way that when this is useful is if you are writing a component that has that could be used in other places, that maybe someone doesn't need to pass that prop down for your component to work, then you give it a default prop, which helps them, which lets them know that they can use to-do list without passing that prop into the component. So they come to to-do list, they see that to-dos is not required, but toggle completed is. This is obviously a bad example because for a to-do list, the list of to-dos should be required, but bear with me here. They see that to-dos is not required, but toggle completed is, and so they can write it like this if they'd like. And that, in theory, in a better example, would make this component work. Okay, so that is default props. Every company that you work for will have a different way of handling this whole prop type situation. So there's going to be companies that are okay with you writing .array, and then later in your to-do, defining what a to-do is. There's going to be companies that want you to have default props and make sure that you're really following is required, and then setting up a list of default props, all those kind of things. So for prop types, keep using them throughout the class so you start getting used to it, and then just recognize that you may have to change some patterns that you've gotten used to when you get hired, and that's going to be very true for pretty much all of everything you learn. Every company you go to will have a different pattern for how they want you to do things. So cool. Yay for default props. Any questions on that? Peachy. It's not default. Okay, good. Let's take a look at training kit and what we're going to be talking about today. So we're going to be going over the React lifecycle and all these lifecycle methods that are fun and awesome. Yay. So this is like this is how your component, how your application runs, how every single component runs from the moment that it gets rendered to the DOM to the moment it gets removed from the DOM. And there's lots of things that happen in between those two moments. And the way that we can, React has given us a way to hook into certain things that happen during that lifespan and run some functions based on the different timing of whatever event we're trying to hook into. So lifecycle methods are also called lifecycle hooks because they let us hook into the component lifecycle. There are three phases in the component lifecycle, and we're going to talk about those today and what happens during each phase and which hooks we have at our disposal during each phase. We're going to talk specifically about three lifecycle methods: constructor, render, and component did mount. So we'll do all of that today. Does anybody know the three phases of the React component lifecycle? Death, bum bum bum. Close. That's not quite. but close. Here we go, mounting, updating, and unmounting, or death, bom, bom, bom. So these are 3 lifecycle methods, but not necessarily the 3 phases. These do come in each phase, but there are other lifecycle hooks that also happen in each phase. Yes, we will see components die. It is true. Mounting, updating, and then cleaning up or unmounting. Cool. Good job. I've got a couple graphics that can help us really learn all of these things. The first one is just right here in our training kit. So let's open this up, open image in new tab, and take a look at it here. All right, and I'm gonna grab my pen. I'm gonna be drawing all over this stuff today. So here are the 3 phases. So we've got the mounting phase, we've got the updating phase and unmounting phase. And during this whole time, we also have these phases that kind of run this way across the board. So a little bit confusing, but that's okay. We'll get it figured out really quick, don't worry. So when we talk about the different phases, we're going to talk about these 3 specifically here, the columns, not the rows. So when a component when we route to a page built by React, and it's made up or composed of smaller components, those components are going to be rendered to the DOM. And that's called mounting. So when your browser is running your React code and going through the mounting phase, it's going to look at each component. It's going to run each of these lifecycle methods. This is not a method. This is just when the DOM gets updated. So when we're mounting a component, the first thing that happens is the constructor gets invoked. And everything that's in the constructor is run. So super gets run, our state gets initialized, and anything else that you have going on in the constructor. Don't worry about this one too much for now. That happens, and then we go down to render. So then the render function runs after the constructor runs. And when the render function gets invoked, then React goes to the virtual DOM, updates the virtual DOM, the comparison between the virtual DOM and the actual DOM happens, and if there's changes, then the actual DOM gets updated. And then finally, we have this new method that we haven't seen before called component.mount. And this function gets run after constructor and render, and after the first rendering happens on the DOM. So who knows what this function is used for? What is the purpose of this function right here? Ooh, nice. Setting state post render. Good. Rendering results of API calls. Awesome. Mounting data from an API. Yep. API calls, loading GIFs, loading screens. Loading, yeah, yes, because that would trigger that. Okay, I'll take that. Loading screens, loading GIFs. Setting state immediately after the render. Yep, so after the render happens, well, when the constructor runs, we initialize our state object. We set the first how we want our state to look like first. Remember, component did mount is for fetching data, doing an initial fetch of data. So a lot of times in our state, we're just going to initialize our state object with an empty array or with some kind of placeholder data until our API call comes back. So constructor runs, initializes our state object with kind of an empty data set, and then our render runs, which gives our user some feedback that maybe we're going to kick off or render a loading screen. Maybe we're going to render like a skeleton of our app first and then just indicate that we're loading data. Then we're going to kick off the actual data call. So yeah, these are all really good. Feeds data to state after component mounts. Awesome. Run a function as soon as the component renders. Yeah, there's some functions that you don't want to run until after you have something on the DOM. So you want something on the DOM to reference. Maybe you're using refs. So this is a good place for that to happen. Also, another thing that we can do here, and that we often do, I shouldn't say often, but sometimes do, is set up listeners. And you get like a Wacom tablet or something. Listeners. So listeners are set up when you have a DOM node to attach it to, right? So if you try to set up listeners in your constructor, that's not going to work because you don't have anything on the DOM to attach that listener to. You can't say, hey, DOM node, listen for this when you don't have a DOM node. So component did mount is a way to set up listeners. We're not really going to do any of that in this class, but I want to talk about it so you guys know where these things happen. And especially when we get to component will and mount, we'll kind of revisit the idea of having listeners. That was supposed to be a star. That was a horrible star. Good. Is refs best practice? Yeah, when it's needed. I should do a write-up of some good examples to use refs with, because we don't go over refs in this class either. That'd be kind of a fun Medium post or something to give to students. Okay, great job. So yeah, those are the mounting phase lifecycle methods. So all of that happens, and when those things are done, then we go into this updating phase, which is just like this is kind of a static waiting phase. We just kind of hang out exactly how we are until something happens. So if someone goes to your website and then walks away from their computer and gets a drink or whatever, all of this stuff will run, and then once that's done running, we just sit there and wait. We wait for any of these three events to happen. What are those three events? Well, we could get new props passed down to our component. We could run set state, or we could run force update, but don't run force update. But that is an event that triggers these changes, but don't do it. So in the updating phase, we're static and just waiting, and our data and everything stays the same until one of these two things happens. We get new props or we set our state. If we get new props, then we hit this lifecycle method, and this method gets invoked. Again, we're not going to worry too much about that one. We're not going to worry too much about this one. Both setting state and receiving new props invoke this function, and then both re-invoke the render function. So render gets invoked many times. We've seen that in set state, right? We've console logged inside our render function, and we run set state, and we've seen that the render function gets invoked every time we run set state. That's a thing. When render function runs again, we go through this, but we're not going to worry about this one. This happens again, and then we get this function as well, but we're not really going to worry about this one. So in this class, we don't really mess with any of the functions that happen in this phase here, just so you are aware. Finally, when our user navigates away from our from that page where this component has mounted and is just hanging out in the updating phase, when it gets unmounted from the DOM and is no longer being rendered, then that triggers this function here. Now, why do you think we need a component will unmount function? Why can't we just take everything off the DOM, and like what kind of function would we have to possibly run after this component gets ripped off the DOM? What would we want to do at that point? Yeah, this is where we do all the cleanups related to the components. So what does that mean? That means turning off listeners. Perfect. Can anyone explain, Andrew, maybe you can touch on this. What do you mean by turning off listeners? What would happen if we don't turn off listeners? Nobody but Andrew. Yeah, you get a memory leak. So what is a memory leak? Is there a simple explanation for a memory leak? Because it is an issue. Yeah, good. So side effects continue to happen. So let's say something that should have already been terminated is still in memory. Let's say you start a listener. Ooh, this is a good one. So what if we add this listener event to a div, a scrollable div in, well, let's see. Let's say this, for some reason, this component adds a listener to a div. Let's see. Now let's do, yeah, we'll do scrolling. So we're adding this scroll event listener. When this component unmounts, that scroll event listener is still there. The event listener has been attached to that DOM node, and it's still there listening on each scroll. It's going to continue to run the whatever callback function you pass into it. So every time you scroll, which you could scroll like 100 times very quickly, this callback function is being invoked. So during this cleanup phase, if we don't unsubscribe that listener, if we don't remove that listener, then we've got this scroll event listener out there that is running a function every time you scroll. Let's say you go back and forth between this page and this component gets mounted 5 times and you haven't set up your cleanup stuff. Well, now you've got this exact same listener, but you've got it 5 times on that same DOM node. And so now as you're scrolling, every time you scroll, you're now invoking this callback function 5 times every time you scroll. So that's what a memory leak is. Memory inside your browser, inside your computer, is the power to run your JavaScript And so if you run out of memory, then your browser can't run your code anymore. So it could happen if you forget the cleanup phase in component will and mount. It could happen that you just break the browser and your user has to exit the browser, close the browser, and restart it. So this is really important that when you add a listener, that happens in component did mount. On component will unmount, you need to remove that same listener. I think, okay, so let's look at John's example. So component did mount, then we'll say we're setting this interval and we're doing something with this interval. When we run component will unmount, we have to clear that interval. So yeah, intervals is a good thing. This is every 45 or every 4.5 seconds, this function is going to run, no matter what, until you clear your interval. So that's another good example there. Cool. Nice. You guys did that all together. You guys planned that, didn't you? Is there a way to tell that we have unneeded stuff running in case we overlooked it? So what I would say, I don't know. I've never looked into that. What I would say is, as soon as you write this code here, always write this code right away. So every time you set a listener, always clear that listener. And I would never move on to something else after I write this before I go and write this part. Okay, good questions. There was a question that I saw. Did we touch on it? I thought I saw a question. Okay, so Alex says, can you give an example of the component receiving new props without user interaction? When data comes in on an API call, then children components will receive new props. So you receive data, you first pass down an array, and then you receive new data, and that you pass down a new array from your state. So that's an example of a component receiving new props without user interaction. Good question. What did Daniel say? User clicks something, returns a function. Oh, yep, and that the other way is with user interaction, of course. Okay. Cleanup, prenup. Every component did mount needs a component will unmount. No, only components, only when you write something with like an interval, set interval, or a listener. Some kind of function that runs, that will continue running even after the component unmounts. But good question. So in this class, we won't ever have that kind of situation. So we won't actually ever use component will unmount. So you'll see component did unmount used without a component will unmount a lot in this class. And it's all for just getting data. That's going to be the main purpose for us to use component did mount. Okay, really good questions and really good answers. Everybody gets 5 points for your Hogwarts house of choice. Okay, let's take a look at another graphic here. I'm gonna pop this over here. So this is just another way to look at this whole thing. We're gonna look at a couple of these and then we're going to look at my favorite one. So I like these because they just kind of help you visually see what's happening with your components. When you start your component and you route, when you go to that route or you go to that page that has your component and it starts mounting, this box is the mounting phase. Actually, everything up to here is the mounting phase. Constructor runs. Don't worry about this one. Render runs and component did mount runs. Then we go into kind of this static. We're waiting for something to happen. So we're waiting. Oh, we got new props, which means we go to component will receive props. Don't worry about that. Then we go to all these functions, and then we rerun or we reinvoke render. And then this one, and then we go back to our hang out and wait phase. And then state changed, and we go through that whole list again. Render runs again, and then we wait. And then props change or state changes, et cetera, et cetera, et cetera. And then finally, we unmount. We go through component will unmount, and that is the end. Let's look at one more. Let's see, where is it? Bloop. There we go. Just one more quick pass. We've got our mounting phase. Component will mount, render, component mount, don't worry about this one. This is like our constructor. So we run through constructor, render, component mount. We're making API calls here. We're setting up listeners. Listeners. Then we're in updation. So we're waiting. Oh, new props, yay. Go through this whole list. Render gets run again. Then updation. Oh, new state. Go through this whole list. Updation. Death. And component will mount. Okay. Hopefully that is starting to clear up, but any thoughts, questions, concerns? Let's see, where was that? Where did that come in? That might have been in this one. So let me show you these real quick. These are the arguments that get passed into these components. So when you see the parentheses here, if you're using component did update, it gets past all of your previous props and all of your previous state. So I'll show you kind of how to use these really fast, even though we're not really going to learn about it. I'll just show you how you can expect them to be used. Stop drawing. Just want to click. Yes. Okay, component update. I think that's an old one that might have been deprecated. These two are a little bit older. So instead of should component update, it's now, where's my, oh, here it is. It's now get derived state from props. Oh, should component update. Well, let's look at my favorite one ever, and we'll see the real truth. Okay, here we go. So this is my favorite one ever. And you're probably laughing at me because it looks exactly like this one, right? Yay, except it's not. It's live and interactive, and you can do this cool thing called unchecking this. Aha! Now we're just showing the most common lifecycle methods. So this is by far the simplest way to look at these, at this whole concept, these lifecycle methods. So these are the most common ones, and really there's not very many cases for any of these less common life cycles. There's very few cases that these other ones should need to be used, like get derived state from props. Doesn't really need to be used that often. Should component update. Doesn't need to be used that often. Get snapshot before update. Doesn't need to be used very often. Okay, these are the ones that are used 95 to 99% of the time. Constructor, render, component did mount. When we're in our updation phase, render, component did update. When we're unmounting, component will unmount. So those are really the only ones that you see very often, and we're not going to learn about this one here. So let's take a look at what this looks like in code. Let me delete everything, clear my drawings. Check Slack. Nice, thank you, Nathan, for passing that to everybody. Oh, the other cool thing about this is we can click on one of these and it takes us to the documentation, which is cool. Okay, so before we take a quick break, I'm going to show you how you would use this, since we're not really going to be talking about it and using it in our class. So component did update is a way to check your, after you get new props, when you receive new props or new state, and the render function runs, then the component did update function runs. So you've got your new props. So props.todos is your new updated props. So it's got all the new data in that array. So when component did update runs, React actually passes in the old props to this function as previous props right here. So how you'll see this in the wild, and a good use case for this is to look at something on previous props and compare it to your current props and see if it changed. For example, right here, typical usage, don't forget to compare props. So we're going to look at user ID. So we're checking to see if this.props.userid is different than our previous props.userid. So maybe someone logged in to our application. So once they logged in, they typed in their username and password. Before they did that, we did not have their user ID. But after they did that, we do have the user ID. So this is null, and this is now some user ID. So this test passes, this becomes truthy. They are different. So we're going to fetch data and pass in the user ID. We're going to fetch the profile for this user. We're going to fetch whatever data this user has. Maybe this is a social media site. So we're going to get their friends list. We're going to get their feed, all the things that we need for this user now that they've logged in. But this function could get invoked multiple times in the lifecycle of this component. And maybe it runs 5 times after our user has logged in, and we don't want to run this function 5 times. We don't want to keep fetching data. So we only want to run fetch data when when user ID is different, when this check comes through truthy. So we're only going to run this function when they're logging in. Otherwise, if component did update, if we go through this phase, if we get new props, if we set state, or if we force update, and we run through this cycle again, we don't want to keep fetching our data. So that's how component did update gets run or is used. You compare props. You look at your new props and your old props. If something changed, run this function. Otherwise, just ignore it. So that's the use case for component did update. And you can read more about it right here. Boom. Not necessarily. I think, yeah, there's different reasons for both ways of doing it. It just completely depends on the situation. Okay, let's take a short break. Yay. Guys, I promise I have been like trying really hard to take more frequent breaks, but with the amount of stuff that we cover in this class, I have not been able to yet. I will continue trying. So we could take a break around 10:45, 9:45 Pacific, and 10:30, 10:15 to 10:30 Pacific. I would love to do like a 9:30, 10 o'clock, 10:30 break, but if we can ever get to that point in a lesson, I promise we will. Otherwise, we'll have these two breaks about 45 minutes apart, and then so I apologize. I know a lot of you want more frequent breaks, and when that's possible, we'll do it. Okay, see you in 5. Okay, sorry about that. Come on back. Okay. All right, we're going to open up a new code sandbox. We get to do some of this stuff in code, yay. Okay, so we're going to make a app here that fetches some data, and when that data fetch happens, we're going to set whatever data grabs to state. In order for this to work, if we want to use any of these component lifecycle methods that we have been talking about, then we need to make our component a class component. So functional components do not have access to the constructor. They don't have access to render, component did mount, component did update, component will unmount. So if you need to use any of these methods, then you need to use a class component. So let's change class or function app to a class. And then we need to wrap our return in the render function, the render component lifecycle. And there we go. Back up and running. Go ahead and let's do this together. So go ahead and do this alongside me here. You can start from this point if you want and fork this code sandbox. So I'll let you get set up there and get your app function or your app component set up as a class component. Okay, so let's set up a constructor. And we're going to call super inside here. And we're going to set up a state object. And let's put an array of doggos on our state object. And we're going to initialize our state, our doggos array, with just an empty array. This is a common way to initialize data that you're going to get from an API. So go ahead and take a second to set up your constructor. All right. So next, where are we going to? Well, let's do this real quick before we fetch our data. Let's add a couple console logs in here. So above our state, let's console log that our constructor is running. And then inside our, excuse me, one second. Okay, a little bit better. All right, inside our render function, we're going to do something similar, but just call it render is running. So just console log something to indicate that our render function is running and indicate that our constructor is running. And then let's open up our console and let's see what we get. So we can see that our constructor gets run first, right? And then our render function. And we know that that's true because that's what our chart tells us. Constructor gets run first, then our render function. We're going to we're going to fetch some data. So what are we going to do to fetch data for this small application here? Hams is already on it. So we're going to use our component_didMount function, and we're going to fetch our data from component_didMount. But we're not going to do an arrow function. I don't know if an arrow function would work. So what the difference here between this is I'm calling a function that is already defined, and this is defining a new function. So we're going to write it this way: component_didMount. And inside our component_didMount, we're going to run fetch. And Hamza, this very easily could work. We'll actually test that and see if it does. Okay, cool. I've always seen it this way, but that is okay. All right, so component_didMount, we're going to fetch some data. So we're going to pass in this string here. Well, let me wrap that in. We'll grab that string, and we're going to put that inside our fetch. And then, let me just give you this whole block of code, because we haven't talked about fetching data yet. Okay. Okay, so we're going to just grab this and put this inside our component_didMount. Perfect. So what this is going to do is it's going to fetch some data, and it's going to return. We can get a response from this API. It's going to change that into JSON, and then it's going to set our state with the correct data. We'll learn about this next week, so don't worry too much about really what's going on here. This just catches any errors that we might have. Just know that we're fetching data from this API, and we're going to set our state with the data that came back from that API. So now let's take a look at our console. But first it's console.log component_didMount. You'll often hear component_didMount referred to as CDM. So console.log component_didMount is running. Okay, now let's open our console and let's see what happened. So our component mounted, we ran our constructor, and then we ran our render function. And then after both of those happened, then our component did mount runs. And inside our component did mount, we run this dot set state. So we're updating our state, which makes render run again. So we'll walk through that one more time. Constructor runs, render runs, component did mount gets invoked, and set state. So when we get new state, that re-triggers of the render function. And if we look at that here, we get our constructor, we get our render, we get component did mount. After this runs, we go into our updation phase. If we run this dot set state, we rerun our render function. So you can see everything that we've coded now in this project happening in this chart here. Cool, so now that we have data, let's open this up and inspect it and see what our data is. We're gonna go to React. We're gonna look at the app component and our doggos array. So we've got 171 doggos. And our array just consists of strings. So it looks like images. So let's go here and let's build out something for our dog images. I'm just going to give you this code as well. Go ahead and just put that right inside where we're trying to, right inside our render function. Yay, now we have our list of dogs. Oh, that cute puppy. With Tigger. This is a really fun API. So you can mess around with this. You can go to dog.ceo/API and get a list of breeds that's accepted. My personal favorite are the Huskies, of course, because how can you not love pictures of Huskies? They're my favorite dog, I think. Ooh, that's a serious Husky right there. Okay, cool. Any questions on what we have done here? Yeah, I think there was a stretch problem to look at the dogs API. Oh yeah. Nice. Oh, good question. How do we do pagination? That gets complicated. This, a lot of times that is set up on the API, like for the Star Wars API. So the Star Wars API is set up where it returns the first 10 in the list, and then it gives you a URL to run for the second group of 10. So from 11 to 20, and then it gives you the URL for the previous 10 and the next 10, and all the way through the list. We could set it up so that we only display 10, the first 10. So we could do, you could set that by const first 10 doggos equals this dot state dot doggos, and then splice out the first 10 of them, and then that gives you an array of 10, and you would map over first 10 doggos. And then you would set up a function that when they click on next, then excuse me, you'd have, or get, we'll just say 10 doggos at a time. And then on state, you'd have something like current page equals 1. So if this dot state dot page equals 1, then this array gets the first 10 dogs. Then you have a button over here with an arrow that when your user clicks on that, it updates your state to 2. And what happens when our state updates? We run the render function again, right? So if our render function runs again, then this would run again and we would get the next 10. This would be kind of a fun thing to do through the rest of the class. You guys want to build this? Paginate through a list of dog images, 10 at a time. No response. Okay, here's the responses. I was watching your faces. All right, let's do it. Okay, so we're going to, this is all, usually for my lessons, I have like a solution for what I'm trying to build on my other screen over here. So we may run into some snags since this is all just like on the fly live coding. So bear with me as we do this. So we want to think through this problem here. We want to display a list of 10 dogs at a time. And we want to have a next and a back button. We're not going to like, you would also want to have page 1, page 2, like be able to jump pages. So that's something you can, we probably won't get to in this example, but something that'd be really fun to work on your own. All right, so we're just going to do this all, we're going to break our container presentational component rule, and we're just all going to do this in one file. But you should break this out into other files, but that's okay. So we're going to have a optional component here that is if, we're going to say if this dot state dot page, what did we call that? Current page is greater than 1, then we're going to display a div that says else we're not going to display anything. Okay, so if we're not on page 1, if we're on any other page other than page 1, we're going to have a back button over here. Let's wrap this in div. Oops, why did that happen? Okay, so that is wrapped in a div. And then also inside this div, we're going to have another conditional element. This dot state dot current page. Well, for now, let's just always have this one. So let's do a div, and we'll say next. Okay, and you can see it up here. We're going to run into a little bit issue with this, but we'll fix it in a minute. All right, so if we click on this next line, we're going to run a function. So our onClick is going to call this dot navigate, and we're going to call we're going to pass in a string next. We don't have navigate, so it's trying to call it, which means I forgot to pass this in like that. There we go. Passing the event. All right, so we need a navigate function, which is going to take in an event and a string. We're just going to call it navigation. We call e.prevent. Oh, this isn't a button. We don't need the event. Just kidding. Okay, we're just going to pass in our navigation string. And if navigation is the string next, then we're going to set state. We're going to increment our current page. So we want to first do, our first inclination is to do this, right? Current page equals this dot state dot current page plus plus, or something like that. If you ever find yourself doing something like this, like incrementing a count, or usually it's counts that kind of get messed up here. You don't really want to refer to old state right here. So instead we're going to pass in a function which is going to implicitly return this. Pass in a function, we return our object of the state that we want to update. And this gets previous state. So instead of referring to this .state.current page, we're going to refer to previous state.current page. And we'll increment previous state.current page and pass that to current page. So basically when we click on this button, we want this to be incremented. So let's make sure that's happening. When I'm doing little features like this, when I'm building stuff, I'm constantly checking. I don't want to build a whole bunch of things out and realize that 5 steps ago I missed something and it's broken. So every time I kind of get to a point that I can test something, I'm testing it. So if I click on here, see, this isn't working, right? So it's a good thing that we are testing this now. So let's first make sure that this is running. Navigate is left. Okay, so if I click on next, so navigate is running, but my state's not updating. I think I have to do it's over here. There we go. Oh, so that's working. All right, so pretty easy. We've done this before. We've got an element with an onClick that runs a function. Okay, let's pass the same exact onClick handler to our back div, but instead we're going to pass in back. we'll say, let's just keep this code here. So if navigation equals back, then we're going to decrement that. So we'll test it. Next gets us to 2. Hitting back gets us back to 1. Cool. All right, so this current page is going to be really important for making our pagination work, because it's going to tell us which set of 10 in our array that we are going to display to the DOM. So we need to make sure that to understand that this is a very important piece in our application here. I'm going to check Slack, see if we've got any. Okay, so Jacob asked, we need return in our set state function. We do have return. We have we do when we pass in a function rather than just an object. This would probably work if we didn't do it this way, but this is the better way to do it. If you're calling this dot state dot something inside here, then it's safer to use previous state. So pass in a function instead of an object. That function takes in previous state as its first argument, and you return the object that you would normally pass into this dot set state. And then our return is happening implicitly with these parentheses. Okay, good question. All right, cool. So help me now, you guys, help me write the logic for this 10 doggos array. How are we going to do this? What do you guys want to do with this 10 doggos? And it doesn't have to be set up like this by any means. We can set this up a different way. Okay, we could write a splice method and use state data to decide which we're splicing. Increment by 10, I like it. It's kind of what I'm thinking. Splice the whole doggos array from 10 times this dot state dot current page to 10 times this dot state dot current page plus 10. Yeah, so this is a really good way to think about it. We have this big, huge array, right? Right now we've got 14. Let's change this back to Huskies so we get a lot more. Let's see what we get. 195. So we've got 195 dog images in our doggos array. And we're going to use the splice method to get 10 images at a time. So if we're on page 1, then we want index 0 to 9. If we're on page 2, we want index 10 to 19. If we're on page 3, we want index 20 to 29. So at this point, you have to think, this starts to get a little bit mathematical here, and you have to go back to your algebra days, and you have to think, all right, if I'm on page 1, how do I get to the number 0 and the number 9? And then if I'm on page 2, how do I get to the number 10 from 2 to the number 19? So we're going to use, you'll notice that the ending of each page is 1 less than 10 times the number we're on, right? So by that reasoning, if we're on page 8, we go 8 times 10 minus 1. The last index number we want to see on our page is 79. If we're on page 15, the last index number we want to see is 149. So now that we kind of have that logic figured out, then we can go and write our code, kind of what was explained up here. So yeah, we can go over, we'll look at splice right now because it's, for splice and slice, I always have to go to MDN. I always have to see what it is again. Yes, and then we'll do some checks to make sure we're okay in our code to stop errors from happening. Okay, so let's go to MDN splice. So splice changes the contents of an array by removing or replacing existing elements. So splice is going to return an array containing the deleted items. So this is, let's see, you may not want to use splice because it changes the contents of an array. So we don't want to actually remove contents from our original array, right? So months, month splice, console log months. Yeah, so this is actually changing our original array. So let's go to slice. So we want slice. I told you I always have to look because I always get confused between the two. One of them changes the original array, the other one does not. Okay, so slice method returns a shallow copy of a portion of an array into a new array object. So if we've got this original array here, 1, 2, 3, 4, 5 elements, 5 strings, and we slice out the number 2, then our output is this right here. If we slice out 2, 4, so this first one sliced out everything behind from the second index to the end. So camel, duck, and elephant. You can give it a starting index and an ending index and only get numbers 2 and 3. So the first index, starting index, is inclusive, ending index is non-inclusive. So when we do animals.slice 2, 4, we get the animal at index 2, at index 3, but not at index 4. So we get camel and duck. If we do 1 through 5, then we get the index 1, 2, 3, 4, and not 5. 1, 2, 3, 4. 1, 2, 3, 4. So we need to use slice to grab the 1st through the 9th. We're going to set it up to grab the first 10 first. So let's just worry about 0 through 9. So when render runs, let's make this a function call. Let's say this dot get 10 doggos. And we're going to pass in this dot state dot current page. So we've got our function. We're not going to use this inside this function, so we don't need an arrow function if we don't want to. That's why I set it up this way. Just to keep things, just for continuity's sake, we'll just make it an arrow function. Okay, so get 10 doggos. We are receiving the current page as an argument. We pass it in right here. So our logic is going to be something like this. We're going to return, return. Oh, we are going to use this because we're going to call this dot state dot doggos. Okay, this dot state dot doggos dot slice. And now we need to pass in 2 numbers. We need to pass in the the first number is going to be the first index that we want to grab. So we're going to say page times 10 minus 1. Hey, we got 1. Well, we should have all the dogs right now because we haven't specified an ending one. So page times 10, let's do this. Let's set this into a variable and then we can look at it in our function call. Const first index equals this. And then it's console.log first index. Okay, so when every single time that the render function runs, which is in the mounting phase right after constructor, and every time we get new props and every time we run set state, our render function is going to run. So every single time that our render function runs, we're going to invoke this function here and pass in our current page. Then when this function gets run, we're going to look at this.state.doggos, and we're going to set a first index to start grabbing from, and we're going to slice this.state.doggos and grab right now just the first index to the end of the array. So let's see what we're expecting. First index right now to be 0, and then if we're on page 2, we expect it to be 10. Yep, that's correct. If we're on page 3, we expect it to be 20. So is this going to work? 2 times 10 is 20 minus 1. Okay, this logic is not going to work. This is going to be for our last. So what's the logic for our first page? You guys tell me. First index. If we're on page 1, we want 0. If we're on page 2, we want 10. If we're on page 3, we want 20. You tell me the logic for that. Okay, cool. This will work. The first index is inclusive. So I like, quit it. We'll get to there. You just relax, okay? We'll get there. Just kidding. You're awesome. We'll check against our stuff here. Okay. Page times 10 minus 10 for the first. So let's try that. Page times 10 minus 10. Yeah, so I think this will work. So we get 10. If page is 1, we get 10 minus 10 is 0. If page is 2, then we get 20 minus 10 is 10. If page is 3, 3 times 10 is 30, minus 10 is 20. Cool. Perfect. So let's test that out and make sure that's what we're getting. Well, let's clear everything. Rerun. 0. Yay, that's what we wanted. So if I click on next, then we're at 10. If I click on next, we're at 20. Next, 30. Perfect. Good job. 40 points for your Hogwarts house of choice, Jamie. Okay, next we want the final we want the last array, or last index. So how are we going to get the last index? We want it to be, if we're on page 1, we want the last index to be 9. If we're on page 2, we want the last index to be 19. If we're on page 3, we want it to be 29. So what's the logic here? How are we going to get to from 1 to 9, 2 to 19, and 3 to 29? Page time 10 minus 1. Yeah. Yes. Let me save this. Well, let's just do this. Page times 10 minus 1. And then I'll show up my render function in just a second. Okay, so let's console log last index, and let's pass last index into here. Okay, 0 to 9. If we click next, we want 10 to 19. Good. This is looking good. 20 to 29. 70 to 79. Perfect. Yeah, this is looking awesome. And we should, no matter what page we're on, let's hit back. 60 to 69. 50. Perfect. No matter what page we're on, we should only have 10 images. 1, 2, 3, 4, 5, 6, 7, 8, 9. Why do we not have 10? Oh, because the last one's not inclusive, right? So if we go look at MDN, so we're assuming that the last index is inclusive. So we're only getting 70 through 78, or 0 to 8. So we're only getting 9 images. So in fact, we don't need to do -1. We want 0 through 10. Then we want 10 through 20, low. And we want 20 through 30. And that will get us images 0 through 9, 10 through 19, 20 through 29. So now let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Woo! Nice, we got 10. Let's go. Let's skip a bunch. So we should have images 119 through, or 110 through 119. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Awesome. Woo, we did it. Yay. Well, we're not quite done yet, but we will take a quick break and then we'll finish this up. Here's the render method. I'll share this with you guys if you want to take a look at any of this code so far. When we come back from break, we'll just talk through all of this. We'll look at our console logs because our console logs are still running. We'll look at no matter what is happening in our app, we're going to look at what lifecycle methods are firing off. And then we'll finish up. We'll kind of clean up and solve for a few edge cases here. And I'll show you a cool way to do that. Okay, we'll be back in 5 minutes. Okay, let's finish this Doggos app up. Cool. So a couple things that we want to do to kind of clean this up a little bit. First, we'll do just a little bit of styling. And then we will, we need a key on here. So we'll do our key, we'll just do our doggo. Okay, we've got our key, that's our source, and our, oh, we do have key, just kidding. All right, it's gonna tell us we want an alt prop, that's what it's, the squiggly line's there for. All right, there was a good question. If there's time, can you show how we get pictures to be the same size? So we can use CSS, that's probably your best bet. I'm going to cheat a little bit and just say, give this a width, which you can do for images. These can take a width attribute and a height attribute. So let's say we want it to be 300 pixels. Then all of our dog images will be 300 pixels wide. So we'll do that. That's this is basically like giving this a class name, going into your CSS and saying width equals 300. So that's a little bit of a shortcut on images, which is cool. Sometimes you want it to be a little more dynamic, so this wouldn't work as well, but yeah, that's what we're going to do to solve that. If you wanted this to be a percentage, then you would have to do that in CSS. Okay, let's take a look at what we have created here. And we're going to take a look especially at these console logs to notice when these console logs are running, which indicate when each of our functions, our lifecycle methods, are running. So looking at our application, we have our constructor, and we know that this is going to be run very first, right? And then when does our constructor get run again? This is a trick question. Those are both false, and I'm sorry that I baited you into this, but this is a trick question. Yeah, constructor only gets run once. So if we look back at our image up here, constructor will only ever run one time during the life cycle of this component. If we unmount it and remount it, then it'll get run again, obviously. But during its single life cycle, constructor only runs once. So let's take a look to see if that is true. So we're going to refresh. We get constructors running. If I click on something and set state, I don't ever see constructor again. So good. Yep, so constructor runs first, and it only runs that one time. Let's refresh. Let's come back to our code. So after constructor, what runs next? True story. Oh, not component did mount. Oh, these are good questions, faking everybody out. Render runs next. So let's take a look. So after our constructor, then our render, and then our component did mount. Now this is important because we kick off, we do some stuff here that could take a little bit of time. And before we start that process, we want to render something to the screen, whether that's a spinner, a loading page or some kind of like skeletal thing. When I say like a skeletal representation of your app, I mean, let me do this real quick. We're going to slow down our network or our performance. So slow, we're going to throttle our network to fast 3G. We're going to go to Facebook Marketplace. So we're on a slow internet so that we can see, here's like a skeletal structure. So part of that, now wait for a second. Here's more of like a skeletal structure thing. We don't have the images, but we've got like the boxes. So some companies do this type of thing where they give you some kind of skeletal structure with this like waving silverly gray line to indicate, hey, this is going to be something and we're loading data for this thing. So that's what I mean by like that skeletal structure. But that would not be possible or that would happen later than we would want it to if render didn't get called before component did mount gets called. So render happens first. Also inside component did mount, we set listeners. So you have to have something on the DOM, you have to have something rendered in order to set a listener up. Okay, so let's look at our app. And we run our constructor. Then we run our render. And then, so this is interesting. We get 0 through 10, right? We get our indexes before we ever get our data. So let's do this as well. Let's just get rid of, let's do this. Let's say console.log inside get 10. And let's do this state.doggos. Okay, so when render gets run, we're going to run this function. Every single time render gets invoked, we're going to run this function. And every time this function gets run, we're going to have these 3 console logs run. So we should always see render, inside get 10, and then 2 numbers. But I wanted to do this so we can see the first time that render runs, we haven't even run component did mount, right? We haven't even fetched our data. So the first time that render runs, and we run this function, and we run this console log, we should see an empty array here. Even though first and last index get set, we're just going to have an empty array, and we're going to return an empty array. So let's take a look at that. Let's clear and refresh. And there we go. So inside get 10. So constructor runs, our first render runs, we're inside get 10, and we have an empty array. Now, why is this an empty array the first time, and then after component component is running, then it's filled array the second time? Yeah, component did mount needs to run to populate the state. Initial state, this is the key part here. Initial state is an empty array. So we run our constructor and we set up our initial state, which doggos on our initial state is what? An empty array. So we run constructor, set up that empty array. We run render, which runs these 3 console logs. So this .state.doggos at this point, since we haven't gone through component did mount, is an empty array. Then we run component did mount, and we wait for the data to come back. When that data comes back, it runs set state, which runs render, which runs these same 3 console logs. But this time, instead of an empty array, we now get our data. And now every single time that we click on next or back, we're running this dot state again. And we're going to get render inside get 10 with a full array and 0 and then 2 indexes. So we ran render inside get 10 and then our 2 indexes. And render inside get 10 and our 2 indexes. Okay, final thing we want to do here. So that is a look at all of our lifecycle methods that we're going to be working with in this class. When they run, why they run, what we do inside them, how we're going to hook into those. Like, this only works because render gets run every single time, right? On set state. So we're going to use that knowledge. We know that render is always going to run after we click on next or back. And so we're always going to rerun this function to get our next 10 or our previous 10 dogs or our next 10 dogs. And 10 dogs gets a new array every single time. And then what are we rendering? We're rendering our 10 dogs right here. So if we didn't know that render was going to run on every set state call, we would have to set this up differently. But because we know that, then we can run this function inside render, and every time we click on next or back, this is going to get run. Gonna get run. Yeah, that's English, right? Okay, last thing we want to do is we've set it up so that we don't have a back button if we're on page 1, which is good because that would take us to index -10 to -1, right? We don't want to do that. That would break our application. So we need to hide the next button if we get to the very end. So we're going to do that now. So what I would do is I would set one more thing on state that says max pages and have it be null to start out. Then when I get my call back and I'm running this dot set state, I'm going to set my doggos and I'm going to set my max pages to dogs is our array, dogs.length divided by 10. And then we want to round that up, so we're going to do math dot round. I think may have to look at the math here. So let's go look at what max pages is. If we have 195 dogs. Oh, it didn't even work. Curses. Did I do something wrong again? Math.round, dogs.length. Oh, dogs.message. .length. Okay, 20. So if I go to page 20, then I want to, that should be 190 through 195, right? Perfect, so that works. Okay, so let's go down here. So now we have the max amount of pages that we want. So we're going to come back to here, and we're going to make this next button conditional on whether or not we are at 20 pages or below. So this dot state dot current page does not equal this dot state dot max pages. If that is true, then we're going to show this div. If it's false, then we'll show null. And then close out our curly braces. Okay, so let's check this out. We're going to watch our current page, and when we get to page 20, we should have doggos here, and we should not see the next. 14, 15, 16, 17, 18, 19, 20. Next is gone, and we should only have about 5 dog pictures here. There we go. Ooh, that's a mean looking dog. Cool. So I think that's where we're going to end today. I would love it if you guys go and style this a little bit different. I was going to, the reason I wrapped both of the back and next is I was going to, the reason I wrapped it in this div here was to make it Flexbox controlled and then split them off side to side. So you'd have next on the left and back on the right over here. If you want to do that, then you don't want to have null. So if you hide back, then next would come over into the middle, right? If it's flexboxed. So instead of doing null, just do an empty div. Cool. Actually, that, oh yeah, empty div without a non-click. Yep, we should be good. I was thinking that if we had an empty div and you clicked on it, it would still run this. But it won't because it's not on this empty div. So it works. Okay, any questions? Whew, that was fun. That was a really cool project. Thanks for suggesting that. Set state and then it re-renders page, populated new state. Yeah, so notice too that every time we run render, we're getting a new array for this 10 doggos array, which means we're going to re-render this entire list right here. So one thing to be careful of is if we use the index for our key here, then we could run into some problems with it rendering new dogs because you're getting a new array with the same index numbers and different images. So you do have to be careful of that. Sometimes key issues happen, and as you noticed right now, sometimes they don't. So, other questions? Ooh, boxer. Yes, I do like boxers. Sometimes I'm like Doug from Up. I'm like, squirrel. Oh, cute. Cute puppies. That is a squirrel moment. Okay, let's see. How would you get the page numbers to be on the bottom of the page so you can click on a certain page? So you could just display a no, let's see. This dot state dot page number. We can display the page number at the bottom. No, current page. So what you'd have to do is you'd have to, there's our current page. You'd have to make an array. Oy. make an array of numbers, use max pages here. On click would run a function that sets current page with what number you clicked on. So you'd make an array, you would render that array across the bottom of the page, and then when you clicked on that element, then it would just set your current page. It would set state, and current page would become the number you clicked on, which would re-render, run this render function, which would run this, and then you get your correct indexes and your correct pictures. And then you could say, you could have a styling, or you could make a class name that says if the current page equals whatever number this is, you could style that differently and like make that number bigger and have all the other numbers smaller so you know which page you're on. There's a lot you can do with this. Pagination is some pretty cool stuff. Did I say curses? Okay, you could also disable the button. Save, can you save that code sandbox? Saved. All right, cool. Yes, I was thinking that might be necessary. Page of max pages. All right, cool. Let's look at today's project. So day 2, we're focusing on render and component did mount. As far as lifecycle methods go, there's not much you have to change in your project to implement this. The biggest change you're going to have to make is in app.js, use component did mount to set your data. Now I know you're not making an API call. I know you're just getting data from a static data file, but I still want you to initialize your state object in your constructor with an empty array, and then write out component did mount, and inside component did mount run this.state and data or posts, whatever you called it. This posts equals wherever you're getting your data from. So run this.set state inside component did mount and initialize your data as an empty array inside your constructor. And then that's the only thing you're going to be doing with what we learned today. The rest of what you're going to be doing is getting into more complicated situations of running logic. So adding a comment. Go through these steps to be able to add a comment in your application. Liking posts, searching for posts, filtering out any post whose username does not match the search term. So those are the 4 goals for today. Throw in a component did mount, write the ability to add comments, like posts, and search. And then, of course, your stretch problems. Cool. So that's it for today. Tomorrow, get ready for higher order components. Woohoo! It's going to be awesome. You guys are awesome. I'll see you tomorrow.